Okay. So like, it's very nice to see so many familiar faces. But yeah, I will start from the event. Today, the Caucasus Real-Time Network's great pleasure to host it. It is first archaeometallurgy seminar titled On the Central Caucasus Prehistoric Metal Production Through Novel Approaches. We aim to create and showcase friendly environment with our outstanding moderator, Dr. Nathaniel Erb-Satullo from Grandfield University, and with our fascinating works of the scholars, MCK Joyce Vinin Hu from University of Oxford. Her topic will be about interpretation, legacy, composition data of copper-based artifacts in Bronze Age Caucasus, technological choice in alloying and recycling. The second speaker will be Dr. Irina Gambashidze from Georgia National Museum, and her topic will be about early metallurgy in Georgia. And the third speaker will be Dr. Khachatur Meliksetian from Institute of Geological Science, Armenian National Academy of Sciences, and his research will be about an overview of prehistoric metallurgy of Armenia, from Neolithic use of metals to advanced alloying techniques in late Bronze Age. And our last speaker will be Dr. René Kunze from the Martin Luther University Halle-Wittenberg. And his topic will be about the importance of Armenian gold from Bronze Age, Caucasus provenance studies on prehistoric gold by use laser ablation ICP-MS. And hereby, I would like to mention just basic house rules. If you are not going to speak, just try to mute your microphone. And if you have any questions, please write in the chat box or click on the raise hand button. So now I just lent my position to Gwen, and she's going to introduce our committee. Gwen?
Yeah, so I'm just going to take a quick moment to introduce our network to those of you who are joining us for the first time today. So we are a group of master and PhD students all working on the Caucasus, and the aim of our network is to bring together regional archaeological, anthropological, and historical debates and discuss current research carried out in the Caucasus. So we are open to the fields of archaeology, history, art history, anthropology, literature, and linguistics, all related to the Caucasus and adjacent regions. Also want to mention that the network is an inclusive and encouraging environment. We put strong emphasis on uniting, transcending national boundaries and enhancing dialogue. We also provide a space for young researchers, especially early career researchers, to present their work, and they thereby facilitate knowledge exchange among scholars and early career researchers. I will now hand over to Ruben to introduce the event program and event moderator.
Thank you very much. So the event will be moderated by Dr. Nathaniel Erb-Satullo. He completed his doctoral thesis at Harvard University with the title Metal Production in the Land of the Golden Fleece, Economic Organization and Technological Change in South Caucasus from 1500 to 500 BC. From 2017 to 2020, Mr. Erb-Satullo was a department lecturer in archaeomaterials at Oxford University. Currently, he is a lecturer in archaeological science at the Forensic Institute at Cranfield University, and the director at large at the American Research Institute of the South Caucasus. Also hereby to mention that he just launched a new MSc program in archaeomaterials at Cranfield University and would particularly welcome students interested in archaeometallurgy of the Caucasus and adjacent regions. Dear Nathaniel, the floor is yours.
Hello, everyone. It's so nice to see so many familiar faces in the virtual audience, as it were. So I wanted to just take a few minutes to kind of introduce the topic, and I promise we'll get very shortly to our speakers and hear their fascinating research. But I just wanted to kind of share a few thoughts and perspectives on kind of the field of archaeometallurgy in the Caucasus and kind of give you guys a little bit of a backwards look and kind of what has come before and kind of looking forward and kind of what are the key questions that this discipline is asking these days. So if whoever's sharing their screen, if you could unshare so I could I have just a couple of slides. Yeah, so it's an extremely exciting time to be working in archaeometallurgy in the Caucasus, and I don't want to kind of jump the gun a little bit with the kind of suite of really fascinating talks that we have planned here, but there's a huge kind of range of research being done in this area, from more kind of field-based work on metal production sites and mapping them and excavating them, both smelting sites, mining sites, workshops, and settlements. I mean, the Caucasus has a huge amount of both finished metal artifacts, which have been studied for many, many years, and then also production sites. So it's, in many ways, it has one of the kind of premier kind of archaeological record for metal production in Eurasia. And so it's a fascinating, exciting time to be working in this area. But I think it's really worth mentioning that the work that my colleagues and I are doing in this area is really a kind of built on a decades and long tradition of research, local research being carried out in the Caucasus by scholars here. And I just kind of highlighted a couple of the kind of range of work being done. Again, surveying and excavating, mining and smelting sites, doing analytical work. There are a number of laboratories that were active during the Soviet period. We'll hear a little bit more about some of that work and the kind of reanalysis and reinterpretation and the new geospatial framework. But there's some really incredible work that deeply informs the kind of ongoing research that we're engaged in today. And I think, especially in archaeological science, there's a danger of kind of assuming that kind of prior research done with older techniques is not worth engaging with. But I think we would do that at our peril. And a lot of this work, even if we're asking slightly different questions or using more modern, more precise methods for analyzing chemistry or whatnot of metal objects, I think that there's a tremendously rich record of work that's been done, starting from really the first half of the 20th century, if not earlier. So I think that's important to keep in mind and look kind of backward and build on that tradition of research. So just to kind of launch our program, I was thinking about kind of several kind of key themes that animate the study of archaeometallurgy. And I think there are kind of four main kind of categories of approaches that I've come up with. One is the study of kind of metallurgical technology and innovation. The Caucasus is distinctive in a number of ways for its use of different kinds of metals. It's quite precocious in its use of certain types of metals, perhaps not the earliest in terms of the use of extractive metallurgy, but certainly up there with many of the other areas in southeastern Europe and Iran, with beginnings of copper alloy metallurgy. And certainly some of the oldest evidence of gold mining is present in the area. There are also some quite distinctive kinds of metal that are being produced that don't seem to show up as much in other areas of the Near East. For instance, the kind of rich tradition of antimony-based metallurgy. There's also quite a lot of interest in trade and connectivity, and this ties into kind of understanding the sources of metal, both of metal objects found within the Caucasus, but also potentially looking at the ways that which Caucasus metal sources may have supplied adjacent regions with raw materials or even finished objects. So this fits in with some of the provenance research that we're going to hear about later this afternoon. I think we're also quite interested in the organization of metal economies. How what this sort of geographies and spatial distribution of production sites is, and what that means for how different communities in these mountain zones kind of fit together, and we're bound together by exchange of metals. Being such a kind of rich, metal-rich landscape, there's some really interesting ways of organizing metal production. And they act as quite an interesting comparison to other parts of the Middle East, where things are done a bit differently. And so because the Caucasus is this region that is very much connected to the rest of the Near East, and indeed the broader Eurasian sphere, there's a lot of kind of distinctive modes of organization that we see in the Caucasus. So I think this tells us and teaches us a lot about the ways metal economies are organized in a global sense. And then there's quite a lot of interest in the kind of broader social and cultural context of metallurgy in the Caucasus, the ways in which metalworkers have treated metal objects and the ways in which they've dealt with them is quite distinctive. And I think this one of the sort of animating sort of themes of Caucasus archaeology in general is this kind of intriguing mix of traditions from the north, from the south, east, west, but also the emergence of a quite distinctive local cultural and social traditions. And so I think this kind of tension is certainly present in archaeometallurgy as well. So I won't say too much more to get us and to kind of get us started. We will come back at the end for some kind of general discussion, but without further ado, let's get to the talks. So I would like to invite Joyce Ho to give her talk.
Hi, let me share the screen now. Hi, everyone. I'm happy here to share with you our research about the technological choices in alloying and recycling in the Bronze Age Caucasus, and actually is relevant to the introduction provided by Nats, because we interpreted the legacy compositional data to explore the metal production in the Caucasus. This is actually my master thesis done back in Oxford, and it was supervised by Nat. So this study, we focus on Caucasus, which is the nowadays Western Georgia. In this region, the copper-based metallurgical industry during the late Bronze Age to early Iron Age was particularly productive, with many smelting sites and artifacts discovered. This was supported by the rich ore deposits, including copper, arsenic, and antimony deposits in both the greater and the lesser Caucasus Mountains. So previous studies have explored the technology and the organization of metal production in this region, but there are still lots of questions regarding the technological choices, the exchange networks, and the nature of recycling in the production. So this study aims to address these questions by analyzing legacy chemical data. We analyzed 5 legacy datasets generated during the Soviet period by Erb-Satullo and her colleagues. So we analyzed a composition of more than 500 copper-based artifacts, and they spread across early to middle Bronze Age transitional period, the middle Bronze Age, and the late Bronze to early Iron Age. We put more emphasis on the late Bronze to early Iron Age period because the sample size of the earlier periods are relatively small. The find spots and the artifact types are well recorded, along with the chemical composition of artifacts. And the chemical composition was determined by chemical spectral analysis, which likely refers to optical emission spectrometry. As the datasets were produced by the same lab, there's less concern with the inconsistency of analytical methods when we combine the data for analysis. Instead of analyzing the data in a quantitative way, we adopted 2 classification systems to explore the concentration of alloying elements. We analyzed the data with histograms with bin width of 1%, and we also categorized the data based on a single cut-off value at 1%. For the binary categorization, copper tin alloys with more than 1% tin, for example, were probably intentionally produced through either primary alloying or recycling. And in contrast, tin contents that are less than 1% were probably unintentional, derived from smelting like accessory minerals or through heavy dilution. The same applied to other alloying elements as well. These two categorizations can accommodate poor reproducibility of data generated by optical emission spectroscopy. It also tolerates the data entries that are non-numeric or contain signs, such as the greater than and the less than sign. This is important because this type of data are not rare in the data set. After classifying the data, we then explore the chronological, typological, and spatial patterns in technological choices, thanks to the well-recorded metadata. This is the graph showing the chronological changes in alloy types of finished artifacts. So for tin browns, we can see that it emerged in Middle Bronze Age and became more common in the Late Bronze to Early Iron Age. This is different to other places in the South Caucasus, like Armenia, where tin browns appeared in Early Bronze Age and became more commonly used in Middle Bronze Age. Unalloyed copper finished artifacts also increased by more than 4 times in the Late Bronze to Early Iron Age. And in this period, we also see a rise of ternary and quaternary alloys with copper, tin, arsenic, and antimony. These are the histograms of tin and arsenic content in different periods. So the white portion of this distribution represents the unformed metal lumps. We can see that these type of artifacts emerged in the Late Bronze to Early Iron Age, and most of them have less than 1% tin and arsenic. We can also see some interesting pattern in the Late Bronze to Early Iron Age histograms. So both tin and arsenic profile shows a sharp peak at 0 to 1%, and they also have a small peak that are roughly symmetrical. So the 8 to 9% and 5 to 6% are the optimal proportion of tin and arsenic respectively. Besides, most finished items and unformed metal chunks have less than 1% antimony and lead. We can see that unalloyed copper were commonly used to produce both finished items and unformed chunks during the Late Bronze to Early Iron Age, though it had become rare since the Early Bronze Age. This trend was possibly because of an injection of fresh copper into the system during the Late Bronze to Early Iron Age, and this was probably resulted from the extensive mining of rich copper sulfide deposits in the mountains. The extensive production of fresh copper unformed chunks also shows that producers didn't cold smelt arsenic ores or tin ores together with copper ores. Instead, the smelting and the alloying stages were separated. We can also see strong patterning in typology. We excluded lead here because it's not a significant intentional alloying element. We can see that producers tend to use tin browns to produce ornaments and weapons. This trend emerged during the Middle Bronze Age, but it intensified in the Late Bronze to Early Iron Age. So as suggested, most unformed metal lumps are unalloyed copper. And for methods and segment-shaped tools were possibly used as an agricultural tool. So these two types of artifacts share similar compositional pattern. They were mostly made of copper arsenic alloy and unalloyed copper. The composition of artifacts suggests that Tim Brown's ornaments are harder than the unalloyed copper and arsenic copper agricultural tools. Although the hardness of the tools is important for their tool effectiveness, because of the abundant supply of copper ores, the tin supply would have been relatively low in the metal economy, and it seems that producers consciously directed a considerable proportion of tin towards the production of ornaments, although its hardness was irrelevant. So we argue that color was probably differentiate the socioeconomic value between the prestige goods and agricultural tools. Color is probably one of the primary determinants in the choice of alloy types. The distribution of tin and arsenic levels suggests that most Tim Brown's artifacts are gold, while copper, arsenic are silver, and unalloyed copper are reddish in color. The use of Tim Browns in ornaments was probably facilitated by the preference of golden color, especially when there was a lack of gold in the Bronze Age Caucasus. We also explored the spatial pattern of the composition of particular artifact types. We found that arsenical copper axes, indicated by the orange dots on the map, were more frequently found in the south of the Rioni River, which cut Caucasus roughly into half. We also see similar patterning for the composition of matches and segment-shaped tools. At the north of the Rioni River, most of these agricultural tools were made of unalloyed copper, and at the south of the river, they were mostly arsenical copper. Their composition suggests that the color differences, so for unalloyed copper agricultural tools, they would be reddish in color, and for arsenical copper, they would be silver in color. These color differences can be perceived by naked eyes. The spatial variation of axes and agricultural tools show a north-south division of the choices of alloys. It is interesting because this variation did not correspond with the topographic barriers. Lowland societies were more closely related to their adjacent foothill, high and highland neighbors, although the Rioni River would not be a physical barrier that obstructs the interactions and communication between the northern and the southern lowland. We suggest that such an orientation of metal economy was possibly due to the supply of ores from highlands to lowlands, because there are abundant ore deposits in both the greater and the lesser Caucasus ranges. Besides, in different topographic zones, there were functionally complementary production sites. Smelting sites were located in the foothill area, while secondary processing workshops were in the lowland. In this way, the metal production in the lowland, foothill and highland were tied together by the production and exchange system. However, it is important to point out that though there are differences in the choices of alloys between the north and the south, the material culture and the copper smelting technology adopted are broadly similar across the entire region. Another possibility to explain this variation would be the socio-cultural differences between the north and south. So communities in the lowland and adjacent mountains may share similar value system of metals, for example, regarding the aesthetics and values of colors. The distributions of tin and arsenic concentration tell us more about the metal production, especially about the primary alloying and recycling. So the sharp spike at 0 to 1% is probably due to a rise of fresh copper supply, as suggested by the increase of unalloyed copper chunks and artifacts. It is also due to the abundance of binary copper tin and copper arsenic alloy. So for instance, many copper arsenic alloy have less than 1% tin, and these artifacts contribute to the peak at 0 to 1% in the tin profile. Some studies suggest that the metal economy that involved extensive pooling and mixing of scrap metals in recycling will have a distribution that skews to 0 like this, like a spike at 0 to 1%. This is because alloying elements were diluted when mixing all sorts of metals together, and some elements were lost. Some elements like arsenic and antimony were lost in volatilization during events of remelting and recycling. However, in this case, extensive pooling and mixing of scrap metals was unlikely to be the reason of this profile shape. This type of recycling also would have resulted in an increase of complex alloys because various types of alloys were mixed together. Indeed, the proportion of ternary and quaternary alloy in Caucasus increased from 5% to around 16% in late Bronze to early Iron Age, but the proportion is actually relatively less. So we argue that pooling and mixing of scrap metals were unlikely to be performed in large scale. But we believe that producers did recycle metals. They did it in another way, because of the observation that there's an increase of unalloyed copper. We argue that they probably mixed fresh copper with melts of tin bronzes and arsenical copper because tin and arsenic are relatively scarce. These alloys have diluted alloying elements, and they contributed to the intermediate composition between two peaks. The small, approximately normal peaks in most distributions, as indicated by the blue arrow, and the left skewed distributions of spears and daggers and also ornaments, suggest that producers practice primary alloying of tin and arsenic in a relatively fixed proportion to obtain alloys with desired characteristics. The primary alloying of tin suggests that local tin ores could have been mined for metal production. It is because when production site was closer to the ore sources, metal workers have greater potential to acquire the ores for primary alloying. In contrast, if the production site is away from fresh sources of ores, producers tend to remelt and recycle their metals, and this will lead to a asymptotic distribution, like with just peaks like at very low concentration, for example, at 0 to 1%. The sources of tin ores in the Caucasus have been in debate, but there are claims of tin sources in the region, which are represented by the yellow ellipse in the map. As the peaks that represent primary alloying are relatively small, the mining of local tin ores was likely to be small scale relative to the copper production. This relative scarcity of tin may increase the socioeconomic value of tin bronze, and this may partly explain why producers prefer producing tin bronze ornaments or like prestige goods. So in conclusion, this study investigates various aspects of metallurgical industry in the Bronze Age Caucasus. The preference of tin bronze in ornament production shows that color was important in determining the types of alloys in metal production. The spatial variation of alloy types demonstrates that lowland societies were more closely related to their adjacent foothill and mountain societies, like in terms of metal economy. But more detailed investigations are needed to identify if this kind of spatial variation extends to other aspects of the production. The data also demonstrates a massive injection of raw copper into the system during the late Bronze to early Iron Age, and this caused a relative scarcity of tin and arsenic. Extensive pooling and mixing of scrap metals was not the major type of recycling in Caucasus, but producers probably recycled metals by mixing fresh copper with melts of alloys. The compositional histograms also suggest the practice of primary alloying in the production. It shows that local tin ore exploitation was possible on a limited scale in the region, but of course, more field and lab research is required to understand this more. Yeah, this paper has been published in Archaeometallurgy and is open access. Yeah, thanks. And I welcome any questions.
Great, thank you, Joyce. We do have some time, as she mentioned, has time for questions before we move on to the next speaker, and we'll kind of come back in for a kind of broader discussion of all the papers. But I think it's worthwhile to have a chance to have people ask specific questions about each paper if we have time, which I think we do. So I would open the floor to questions. Please either raise your hand and I will call on you, or type into the chat. And I will either read your question or call on you if you would like to speak. Khachatur Meliksetian, would you like to ask a question?
Yes, thank you. So thank you for the interesting talk. My question is, you mentioned tin sources and said that probably local tin sources were used to produce tin bronzes. So my question is, so a few decades ago, Caucasus was considered as a region where no tin deposits exist. So what's changed in the last decades? Because and what's the evidence that these tin sources, so-called tin sources, were used in antiquity? Do you have any data on concentration of tin in these deposits, on presence of primary minerals like cassiterite or stannite, or it is just few ppm of tin present as an impurity in primary sulfides? Because this is principal questions. We need to be very careful when we integrate geological data into the GIS, into geographical information system, and just say, oh, there is a tin deposit here. We need to be very careful here.
Yeah, thanks for your question. I totally understand it, because there's much debates regarding the presence of tin ores in the Caucasus, because some believe that it's even supplied in Mesopotamia. But yeah, like the most of the geology in the South Caucasus are basic and ultra basic. So people tend to believe that it doesn't favor the mineralization of tin. So apart from the slide that I shown before, like the yellow eclipse, that a study by Artefacts and proposed that there's tin deposits in Abkhazia, Upper Svaneti, and Guria. Apart from this, actually there's also a study by Nat. So he analyzed slags and he found that there's cassiterite, the use of cassiterite in the production of copper tin alloy in the region. So the people tends to believe that producers would use tin ores to how should I put it? So tin ores, it weighs much more than tin metal, so it is quite difficult more, maybe I should say, is more difficult in terms of logistics to transport a large amount of tin ores from one place to another than to transport tin metals from one place to another. So the use of cassiterite in metal production seems to point to the possibility that the cassiterite are from the sources that near the production sites. So there's possibility that is in Caucasus, but of course we still have no evidence in terms. We have little, or like it's not really conclusive evidence of geological presence of tin deposits in the region. Yeah, like I think we need much more evidence to confirm this kind of speculation, but I think this is still a possibility. Yeah, I hope that I answered your question.
Yeah, so I can provide a little bit more context about that. Cassiterite found it was cassiterite found in the slag adhering to the interior of a crucible at a site that was mostly engaged in copper smelting. But within this like thin slag glaze, there were particles of partially reacted cassiterite along with other heavy minerals, which suggests an alluvial origin. And you're quite right, Khachatur, that when you find these kind of references to deposits, without too much information, you kind of note it, but don't necessarily know whether it's, economically viable back then or today or whatnot. But the fact that we found this, crucible with cassiterite in it close to 10 kilometers away from one of these places that Tavadze and Sakvaradidze, mentioned, the Vakhtjvari ore deposits. The fact that we found it quite close to that area is indeed highly suggestive. But that crucible is, at least at present, is unique. And I looked for more pieces of those kinds of crucibles at this smelting site and didn't find any. So we don't know how much they were doing, but the evidence from that crucible shows pretty unequivocally that they were exploiting alluvial cassiterite, in these remote kind of hilltop smelting or foothill smelting sites in Korea. We have some questions in the chat. Joyce, can you see those?
Yeah. For the first question, do the materials contain chemical fingerprints which can be used to trace the movement of the metals? Yeah, actually we did some regional analysis. Actually, I didn't show it here because of the time constraint, but I can just share it now. Oh, wait. Yeah, so this is a regional distribution of tin concentration. We did try to see if there's differences between the distributions of the tin concentration to see, if one region intensively recycled metals and another region intensively produced tin alloys. And this may show a flow of tin bronzes from one region to another. But we can see that these for Northern Lowland, Southern Lowland, and Southern Highland, they have some similar pattern. And for Northern Highland and Inner Caucasus, it's a little bit different. But to be honest, I think it's quite hard for us to have a conclusion whether these region exports tin bronze or primary tin alloy to another region. Yeah. So, and because there's another concern, because I know that there's some other studies that show that explore the ubiquity of particular alloy types to trace whether the alloys was transported from one place to another. But because this region is smaller than the region studied in studying those research. So it's hard to get a high resolution of transport of metals or like differences of metal alloy ubiquity between different regions to understand the movement of metals. Yeah. Yeah. Please. Yeah. Sorry. I for my work. Yeah, I published in Archaeometry, and Magda has answered it for me. Thanks. Thank you so much. And another question. My question is about the locales of arsenic in southern Caucasus. Are there any, or is it polymetallic arsenic-bearing copper which results in copper-arsenic alloy? Yeah. So I think the evidence that there's a abundance of unformed metal lumps with less than 1% tin and less than 1% arsenic would be good enough to explain that it seems that the sources that produces exploited is not like polymetallic arsenic bearing copper. And actually there's one study that analyzed the copper deposits. I think it's in the deposits are in the Greater Caucasus, but I can't exactly remember where they are. And it shows that they have a really low concentration of tin, arsenic, and antimony. So these elements should be added to the alloy intentionally instead of like being the dirty components within the ores. Yeah.
Thanks, Joyce. Our next speaker is Dr. Irina Gambashidze of the Georgian National Museum, who's been engaged for decades in some really fascinating field and laboratory research on Caucasus metallurgy. So she will speak to us on early metallurgy in Georgia, and she's going to give her presentation in German, but Gwen will give a summary afterwards. So without further ado, Dr. Irina, please, you have the floor.
Thank you very much for your attention. My lecture is in Germany. My English language is so bad, and I can my lecture in German. So, vielen Dank für Einladung, und möchte ich kurz jetzt über die, so, jetzt das ist das ja, warten Sie. So, die alte Metallurgie in Georgien, eigenermaßen, das sind die so viele Ressourcen im Kaukasus, und die sind also so im 19. und ab 19. Jahrhundert bis zum 20. Jahrhundert sehr gut erforscht. Das war die Großkaukasuskammer in Svanetien, Abkhazia und Raja. Und nachdem das die Deutsches Bergbaumuseum Bochum zusammen mit dem Nationalmuseum und am Anfang mit dem Archäologischen Forschungszentrum zusammen in Kleinkaukasus dahin gekommen sind, da haben wir die neue Richtung in Archaeometallurgie, und mit unserer Kollegin aus Deutsches Bergbaumuseum haben wir also interdisziplinäre Forschungen geführt. Also die letzte unserer Grabungen, so 20 Jahre, so unter 22 Jahre, wir arbeiten schon zusammen und haben wir einigermaßen sehr viel zusammengestellt und sehr viele neue Entdeckungen bekommen haben. Also die Svanetien so im Gebiet von Mestia haben die im 20. Jahrhundert hat Herr Chartolani so eine Sargasch hat die ausgegraben. Das ist eine Kupfer, so eine Lagerstätte, und mit diesem ganzen Menge Kupfer, also Arbeitsgeräte, dafür sind auch die ganze Schläge dazu, und in der Mitte, in der dem Eingang haben Sie eine der also Schafthohlaxt gefunden mit dem, die ist so eine Kupferaxt, die datiert man in der 3. Jahrtausend vor Christus. Also in Racha wurde auch, wo mein Vater auch dahin gearbeitet hat, das war in Chornali und Gebi und Chirchi und so weiter. Und die waren auch die Antimon, Arsen und Kupferlagerstätten zusammen ausgegraben und geforscht. Aber danach gibt es auch die ganze, also teilweise sind die nicht publiziert sind, aber jetzt wird das vorbereitet für Publikation, was im Racha jetzt passiert wurde. Also die letzten 20 Jahre, seit 2004, so 18 Jahren, arbeiten wir mit dem Deutsches Bergbaumuseum, mit Herrn Stöllner und mit Herrn Hauptmann zusammen in Südkaukasus, in Saktrisi hier, und haben wir so ganze Menge ganz frühere Bergbau hier, so wie die Kupfer, auch die Goldbergbau zusammen so ausgegraben und erforscht. Da sind die ganze Menge neue Informationen in der Forschung, die reingekommen ist. Und ich werde jetzt ganz kurz über die alte Metallurgie sprechen und Bergbau, Metallurgie und mit der Produktion dazu. Ja, das ist jetzt die Madneuli, so eine ganz wichtige Lagerstätte in Georgien. Das wird jetzt hier die Gold, Kupfer und die ganze Menge so die Erzen abgebaut. Das in der alte Bergbau war, das hier auch so mit dem Nachweis, dass die hier die Gruben gefunden wurde in 50er Jahren. Also, aber die werden nichts erforscht und das sind nichts erhalten. Wir haben nur die Spuren dahin gesehen und dazu noch die ganze Menge Arbeitsgeräte dazu. Aber zurzeit, wir dürfen nichts mehr nach dem Saktrisi-Sprengung. Sie wissen, dass die Saktrisi gibt es nichts mehr, die wurde gesprengt und deswegen, dass diese Spuren, das war nicht kartiert und auch nicht dokumentiert von der in 50er Jahren. Das gibt's nur die Nachweise, was wir dort ein bisschen, was die Spuren gefunden haben. Das sind die gut dokumentiert. Also das wurde in Postiskedi, das gibt's auch nichts mehr, eine der frühesten Kupfer, Grube und dazu, das ist also Saktrisi, so Erzlagerstätte, das ist, Saktrisi wurde so eine ganze große Lagerstätte, das sind die 5 so die Gebiete dahin, also der Goldbergbau wurde in Kachagiani so Berg da abgebaut und hier, das ist die Postiskedi. Aber das ist also so halber, also so 500 Meter weiter von Saktrisi Grube. Also da wurden also ganz neue Ergebnisse auch dazu, dass die ganze alte Metallurgie in Schulaveri-Shomutepe-Kultur in Archaeometallurgy gefunden wurde. Das sind eben Grabungen von Herrn Hansen mit Solave und die haben ganze neue, jetzt das sind die so Siedlung Araulo und hier haben die hier die ganze früheste Metallurgie, das datiert man, die haben mit 14 Daten um 5 also um 6000, so, die sind alle so mit dem Erzen drin, also die waren in einem Haus und da sind so kleine Metallfunde. Und eine davon, das hier so kleine Perle wurde in Bochum das untersucht, das ist jetzt mit dem Zinn, also Anteil. Aber das ist ein Prozentzinn so ungefähr und aber das ist jetzt, weiß ich nicht, also das ist also die metallurgische Produkt, aber, oder das ist nur die gediegene Kupfer. Das haben wir bis jetzt nicht bekommen, weil die Korrosion ist sehr stark hier. Und deswegen, das sind die jetzt erste Nachweise, dass irgendwo muss man auch Kassiterit irgendwo sein. Das kommen auch die Informationen aus Geologen, die in Gegend arbeiten. Und dazu sind auch diese 3 Tiegelfragmente auch, die so ein bisschen so Kupfer erhalten haben. Und die sind jetzt auch so in Bochum auch so analysiert. Und da hat mit Hauptmann und mit Jansen, da haben sie alle so, nehmen die teil mit dieser ganzen frühere, also mit dem Tiegel zu untersuchen. Und das ist jetzt uns steht noch vor, die ganze Analytik davon zu machen. Also eine der frühesten sind auch die in Chramys-Didigora, die wurde in 80er Jahren ausgegraben von Tamas Kiruadze und danach wird das so kleine Perlen auch und die tragen auch so ein bisschen Zinn drin und vermutlich, dass irgendwo muss dieses Erz hier vorkommen oder muss man das suchen, wenn das sowas eine Zinnerz, also Kupfererz irgendwo gibt, sowas mit ganz wenig Zinn drin. Also da sind die das ist Kassiteriten vorkommen, die sind also ganz kleine Erzgänge, musste eigentlich sein zum Fluss Chrami. Das ist ja nicht weit von Bolnici und die Geologen meinten, die haben Nachweise davon, aber ich selbst, das habe ich nicht bekommen. Deswegen kann ich nicht beurteilen, aber also zurzeit sind das jetzt ganz wenige Zinnanteile sind in dieser Kupferstücke auch drin. Also im 5. Jahrtausend wird datiert. In letzten Jahren haben wir jetzt in Zezwebi daneben den Saktrisi, das sind die also Bergbausiedlung, wo wird die Golderz und der Kupfererz weiter bearbeitet. Bei diesen Plätzen, die sind ja also teilweise sehr ganz große Chronologie, also die ganze also aber Chalkolithikum, so frühere Chalkolithikum. Wir haben jetzt die neuen Daten, die datieren das Anfang 5. Jahrtausend, Ende 6., Anfang 5. Jahrtausend. Und dazu sind wir jetzt gekommen zu der chalkolithischen Schicht hier mit dem so eine Gussform, mit dem Axtgussform. Das ist eine Schaftloch-Axtgussform und eine große Tiegel dazu. Das sind die in die Grube. Die Grube wurde von also so eine ganze Menge, die ganze Komplex ist das mit dem Keramik dazu und die gehört auch zu so eine Sioni-Gruppe von der Sioni, so eine Keramikgrube und deswegen Sioni-Zoppi und das in diese Gegend sind auch so für diese Zeit sehr also charakteristisch diese also einheimisches Keramik hier, ja. Das sind nicht poliert und auch die mit dem Obsidiananteile drin und das sind so handgemachte Keramik und dazu noch diese Axtgussform wurde für uns eine sehr ganz sensationell geworden und dazu noch die mit dem C14 Daten jetzt. Also das sieht so aus nach dem Anteile, dass wir alles zusammengeklebt haben. Das ist hier der Abguss, was wir hier so gemacht haben. Aber jetzt muss man ehrlich gesagt, dass Axt wird danach geschmiedet. Also das sieht so aus und das sind die Äxte, das in Gegend von also Machavera-Flusses und Pinesaure-Flusses ganz häufig kommen. Also die sind insgesamt so 10 Stück in Georgien entdeckt, noch die weitere 12 sind in Armenien gefunden. Aber das sind die Sachen, das sind die Äxte, wo die Bergbau gibt. Da sind die immer so, kommen vor in der ganzen Georgien und auch in Kleinkaukasus oder Großkaukasus kamen, die sind nur die im bergmänische Gerät, also wo die Bergbau ist, da sind die nur die entdeckt worden. Und die Tiegel wird jetzt untersucht und also die ist ja mit dem Kupfer, das ist also der Kupfer. Und Kupfer wurde dahin geschmolzen und deswegen also wir versuchen jetzt zu stellen, da ist das jetzt Kupfer von Saktrisi oder von irgendwo anderes gebracht, weil Z2-Besiedlung, das ist eine sehr große Besiedlung, 62 Hektar und überall sind nur die Arbeitsplätze mit dem Werkstätte und mit dem also die ganze Arbeitsgeräte kommen auch dazu. Eine neue Entdeckung, was wir jetzt hier haben, das sind die, das ist in Orchosani. Wir haben die Orchosani jetzt in 2015 ausgegraben. Das war bei BP-Grabung. Und das ist jetzt eine der wichtigsten Fundplätze, weil die datiert man in die Mitte 4. Jahrtausend vor Christus und einigermaßen, das sind so viele Metallstücke, das ist 34 Metallobjekte und alle kommen von dieser Zeit. Und da sind auch die mit Tiegel und mit der Gussform sind in der Grube zusammengefunden. Eine ganz wichtigste Funde ist diese Hacke hier, weil die Hacke ist ganz seltenes Stück und die ist Zinnbronze. Da ist ja doch eine so irgendwie 1,7% Zinn drin, aber es muss eigentlich so eine mit ferner Handlung hier gekommen sein würde, weil diese Axt ist einzige in Georgien gefunden und ich kann Ihnen zeigen, also die Gussformen von den unsere Tiegel hier und Gussform aus Zezwebi und da sind die von Gabristan und die Gabristan, also das sind nur diese Zentren, musste eigentlich gewesen sein, weil die datiert man auch im Ende 5. Jahrtausend so und mit diesem Tiegeln und hier kommt auch die Gussform auch, ja. Und da habe ich jetzt eine Karte zusammengestellt. Wie sieht das aus mit diesen Pickaxe und mit diesen Gussformen hier? Die Gussformen sind nur so in Zezwebi und in Tepe-Gabristan in Iran entdeckt und die Äxte sind also in Armenien und in so Georgien, in Zentralgeorgien und gibt es auch in die Gräber in Maikop. Also wenn wir hier jetzt sehr gut kann man das sehen, wie hier so um die Bergbaugebiete diese Äxte verbreiten sich. Also und dazu sind auch diese Hacken. Also diese Hacke hier in Orchosani, das ist direkt an die Grenze mit Türkei. Und dazu sind also 4 Stück sind in Maikop gefunden, eine ist in Georgien, eine ist in Eridu und 2 sind in Susa. Also da sind so einigermaßen ganz wichtige Funde zurzeit, das zum Forschen. Aber wieso kommt jetzt in Georgien das Zinnbronzen, das muss man eigentlich, das ist ein Fernhandlungsprodukt jetzt. Also das ist nicht einheimisch, weil für diese Zeit so eine also mit dieser Gussformen kennen wir das. Hier kann man auch mit dem Schaftlochäxte auch dem Hacken so vorbereiten. Aber hier die Produkte hier sind nicht so häufig kommen die sind ganz seltene Stücke jetzt, ja. Und jetzt also meistens in ganz frühere 5. Jahrtausend fängt in Georgien so Arsenik, also Arsenkupfer so vorzukommen. Und deswegen sind auch die Nachweise davon, die mit nickelhaltige Kupfererze, mit Kupferobjekte und die musste eigentlich oder die Erzen sind transportiert oder das sind noch die mit Nickel, so Produkte, selbst die Fertigprodukte. Aber zurzeit diese Objekte, das ist Kuraxis-Zeit und die sind jetzt in den 5. Jahrtausend, so was die einige Maßen gibt, so 5 und 6 Stück so, also so eine Stile, die sind auch von nickelhaltig sind, ja. Und also was wir hier jetzt ganz wichtig finden, das sind die verschiedenen Legierungen, fangen in so 4. und 5., Ende 5., also so Anfang 4. Jahrtausend auf. Und einigermaßen das bedeutet, das sind eben also ganz wichtige Produktionsprodukte, einheimische Produkte, ja. Also jetzt haben wir so mit dem Deutschen Bergbaumuseum so ganze Menge Proben das kommt jetzt von der Dissertation Iraklicha Paritze, hat er das so geforscht, also die ganze Erzen aus Groß- und Kleinkaukasus kamen und auch die Objekte, ja, auch das sind die 1. Jahrtausend und da sind auch die bis zum also 2. Jahrtausend, so Ende 2. Jahrtausend und erst Anfang 1. Und das sind hier so ganz wichtige Punkte. Diese 2 Stück sind, die kommen gar nicht, so, das sind nicht Einheimischen. Deswegen, dass die mit dem also Erzen, die haben gar nicht so mit, also das sind die jetzt die Erzen aus Magneuli und daher sind noch die welche aus also Großkaukasus kamen, aber die 2 hier sind irgendwo anderes gebracht sind und da muss man wirklich so ganz, also aber dieser Typ von der Axt, das ist so ganz, ganz bekannt von in Armenien und die kommen aus also Mesopotamien auch. In Mesopotamien gibt es dafür ganze frühere Stücke auch davon und die datiert man auch in 2. Hälfte, 3. Jahrtausend vor. Und jetzt haben wir hier so ganze frühe Zinnbronzeobjekte. Das sind die von Delisi, so kleine Stücke, aber die sind also Ende 5. Jahrtausend und auch die Orchosani wird ein 4. Jahrtausend und das ist jetzt eine Stil aus Kuraraxi-Siedlung Sakochavi bei Borjomi. Und deswegen, da sind die so eine, also erste Nachweise mit Zinnbronze oder mit dem also Erzen also das sind also, aber dann in Delisi haben die auch die Abtröpfe. Das bedeutet, das war so eine kleine Stelle, wo die geschmolzen wurde. Deswegen, da gibt es nach die ganzen Nachweise davon, dass die ganze Komplex hier so mit dem diese Abtröpfen und die kleine so Schlacken, das musste eigentlich auf dem Ort also sein und dort wird das gemacht. Also das gibt es noch mehrere so kleine Nadeln oder das sind nur die 5 Stück insgesamt. Jetzt habe ich hier noch 2 gebracht und dazu sind auch so ganz wichtige ja, also das ist jetzt ein Grab aus Quarzchela, was jetzt ganz Kuraraxis-Siedlung ist, datiert man so um 3000. Und im Grab gibt es ganz unterschiedliche Legierungen. Das bedeutet, die Farben, hier wird das mit dem Arsen und Stibium gefertigt und es gibt auch die mit dem Arsen, ist ja 22%. Das ist sehr viel Arsen, deswegen die sind so eine silberne Farbe, die tragen und dazu ist noch also Stibium dazu an Antimon. Also diese Antimon fängt in Kuraraxis an, in Kuraraxis-Zeit an und diese Legierungen kommen so teilweise ganz häufig vor. Und eigentlich das sind die Perlen auch, das ist Arsenstibium auch, die sind auch so ganz so silberne Farbe und einigermaßen, das ist eine Perle hier, so mit dem reinen Stibium ist dazu. Und diese Diadem, ganz berühmte Diadem, die hat so ganz wenig Goldanteil drin. Und einigermaßen, die wurde auch wie Goldfarbe, so haben sie das auch so mit dem Arsen und eine hochhaltige Arsen ist drin auch und deswegen dieses Stück wird also ganz selten hier kommen jetzt, ja. Und da sind jetzt die Arsenkupferobjekte von Kuraxis-Zeit und auch diese Anhänger, also Ankeranhänger, die sind aus Arsenkupfer gefertigt und der hat bis zum 17 bis zum 21% Arsen ist drin und deswegen die Farbe ist so eine glänzende. Diese Farbe ist nach der Restaurierung so rausgekommen, weil also am Anfang es war nicht bekannt, weil auch die alte Publikationen, die sind nicht so richtig analysiert sind. Dazu jetzt sind alle diese Antimon-Anhänger. Da gibt es eine wunderschöne Kette in Armenien mit diesen Antimon-Anhänger. Auch die sind jetzt da überall, tauchen in Georgien auf, in Kuraxis-Zeit. Und die Lagerstätte, die Antimon-Lagerstätte wird ja bekannt in Racha. Bis jetzt ist die Racha bekannt. Ich glaube schon, es kann sein, die Khachaturian Hilfswehr kann sein, in Armenien sind auch so irgendwo die Antimon-Lagerstätte. Und aber die wurde im 3. Jahrtausend abgebaut. Das wird jetzt von Gobejishvili ausgegraben und das wird also danach später wurde die im 3. Jahrtausend datiert. Also da sind die ganze Menge antimonhaltige Äxte und diese antimonhaltige Äxte sind also nicht nützlich so für die wirtschaftliche Nutzung, weil die sind sehr leicht und sehr zerbrechlich sind und deswegen die sind irgendwie wie Zepter so benutzt. Also da habe ich so eine ganze eine wunderschöne so Entdeckung. Hier haben wir im Ratchas so in Depot gefunden. Das sind die Schlacken von Antimon. Und das ist eine Perlengussform und dazu passende Perle. Aber die Gussform kommt aus Khachuri und Perlen sind aus Kreta. Die sind jetzt so ungefähr 200 Kilometer voneinander entfernt, aber trotzdem, die sind so ganz tolle Funde auch. Und die Antimon, also Schlacken wurden in Bochum analysiert, ich glaube, der Hansen hat das gemacht und also das sind sehr interessant, das ist jetzt die Erzen von der Material, also Rohmaterial von der Racha. Wir waren da in diese Gruben hingekommen und haben wir einigermaßen die Erzen auch gesammelt. Also deswegen, dass die ganze diese also Untersuchungen wird also von Hauptmann und von Janssen jetzt bearbeitet und also eigentlich so ganz wichtig. Jetzt, das sind die Objekte, die Antimon-Objekte, das hat ich mit meinem Vater zusammen ausgegraben im Borjomital und die sind alle antimonhaltig. Und das haben wir jetzt festgestellt, dass die kolchische Axt, das ist die ganz früheste kolchische Axt, die ist im Komplex, die ist in eine gute Grube gefunden, in dem Grubengrab. Und bei den Männern, wo werden die Äxte, also die antimonhaltigen Legierungen, nur die bei Männern also benutzt, aber bei den Frauen gibt es gar nicht so was, die Legierungen. Deswegen die Farbe, diese silberne Farbe sind geeignet für den Priester, für die männliche, so die Priester. Und die Frauen tragen für diese Zeit Kupfer, Arsen-Legierung, aber ganz wenig Arsen. Es muss man auch die rötliche Farbe haben. Aber also hier Zinn wird nicht benutzt. Zinn sind nur in die Waffen oder in den Dolchen oder in der andere so die benutzt. Und deswegen die Antimon wird für diese Zeit, für 2. Jahrtausend ganz häufig vorkommen. Und die sind also zum Beispiel die hier hat 1% Stibium. Das ist wirklich so eine silberne so Pulver ist drin, ja, als wir dort also die Proben genommen haben, da hier überall, da kommen alle diese Pulver raus, so ganz wie Silber sehen die aus. Und deswegen, das sind die jetzt die Rohr-Antimon-Perlen aus verschiedenen Gräberfeldern. Es gibt die ganze Menge hier in Georgien, so, aber die sind jetzt zurzeit eine der schönsten Perlen. Die war in Bochum ausgestellt und also auch in dem 2. Jahrtausend so, die kommen ganz häufig, kommen nur in die männliche Gräber. Den Frauengräber gibt es keine Antimonperlen. Also und in der 16. Jahrhundert, so Ende Mittelbronzezeit, kommt erst die Eisen. Eisendolche wurde in Kurgan gefunden, in Bedeni, und seitdem tauchen so einige Objekte auch in Tiefland, so wie in Tbilisi, so in Treligorebi-Gräberfeld, gibt es auch in Dmanisi und gibt es auch so unterschiedliche so Lokalen, wo die einzelnen Stücke, aber die werden von der alten so Formen übernommen. Ja? Und da werde ich jetzt ganz kurz über Gold reden. Das ist jetzt Aktrisi. Dieser Berg gibt es nichts mehr, weil das haben sie gesprengt. Hier ist so eine Grube, ist hier jetzt, also gibt es überhaupt nichts mehr. Und das ist unsere Grabungsfläche, die ganze Minen hier so mit dem Erzgängen und mit dem ganzen, also Erzgewinnung und ganze Objekte werden hier zusammengestellt. Das ist um 12.000 so Schlägel und also Ambosssteinen, Schlägel, Pochsteinen und also das sind mehr die Mulden und so weiter. Das sind die Sachen, was wir hier so die ganze wichtige Punkt hätten, also oder hatten. Also das wurde unter Tage die Grabungen geführt. Herr Stöllner hat hier so die ganze Gruppe zusammen mit dem Studenten und die Doktoranden und Doktoren und das ganze Team war dabei und haben wir hier so und die Galerie sieht so aus. Das ist jetzt die moderne Grube hier, das wird ja modern abgebaut und hier sind die alte Bergbau. Und diese Bergbauspuren sind ja sehr gut erforscht und ich bin glücklich, dass wir diese Dokumentation ganz toll gemacht haben. Ja, da sind die ganzen Nachweise, das sind die Kulturschichten hier, was die mit dem Gold so gut also verfüllt sind, weil das haben wir, jeder Punkt ist sehr gut also dokumentiert und sehr gut erforscht und damit die Analytik gemacht. Jetzt kommt unsere große Publikation dazu, aber gibt es da einigermaßen die ganze große Publikationen inzwischen. Und da gibt es auch die Dissertation von Herrn Jansen. Und da sind wir also ganz froh, dass irgendwie diese Dissertation entschieden wurde. Ja. Und hier sind die ganze Menge Arbeitssteine, das sind die Galeries hier so und die Gruben, wo die ganze Arbeitsspuren hier kann man gut erkennen, ja, mit dem Holz, mit dem Knochengeräten und mit dem Depots. Das sind die also Steindepots hier, so so Werkzeuge-Depots. Und hier ist der Abschlag, die letzte Abschlag sieht man ganz gut hier so mit dem Schlägel, und deswegen, das hier kann man so gut, und davon gibt es auch die ganze Menge Datierungen. Mit Keramik gibt es auch dazu, das gehört zum Kuraxis-Zeit, so 34. Jahrhundert vor Christus bis zum 26. So kommt der Dach nur vor. Und dazu sind auch die ganze Menge, also Produktion hier, so, aber keine Metallstücke, ja. Das sind die ganz wichtige Produktion. Jetzt wird ja von Frau Tamasashvili die Dissertation über die Schlägel fertiggestellt, und im nächsten wird sie seine Doktorarbeit abschließen, und wir warten alle auf den. Und dazu kommen die viele Fragen. Ja, das ist jetzt Saktrice, Postiske, das ist eine Saktrice, also Erzlagerstätte. Das ist hier, wird hier heute als georgische Wirtschaftsquelle so gearbeitet. Und hier haben wir auch die Siedlung so in 2012 ausgegraben mit dem chalkolithischen so Gruben, mit dem chalkolithischen Häuser, und ein Haus erhält sehr viele also Bergbaugeräte drin, in der Haus war drin. Aber das gibt es nichts mehr, leider. Das sind jetzt alles schon, also das ist jetzt die Saktrice liegt hier, und das ist jetzt die Saktrice, so Erzlagerstätte, das hier, und das ist die Zezwebi-Siedlung. Inzwischen so Goldträger, Flüssen, da sind die Machavera und Tamblutka, und hier haben wir sehr viele wichtige Entdeckungen gehabt. Das sind eine ganze Menge Arbeitsplätze, so mit den Werkzeugen dazu, und das sind auch diese Werkstätte hier. So, das ist die zwei Werkstätten. Eine ist die ältere, wird hier so als Grube verzeichnet, und da oben ist die Etappe davon. Davon gibt es auch die C14-Daten, aber die habe ich nicht jetzt dabei, weil da haben wir jetzt die ganz frisch bekommen. Deswegen könnten wir das gar nicht so jetzt zusammen. Ich war vor einigen Tagen, habe ich die nun bekommen. Und hier wurde einigermaßen, dass der Kupferschmelzplatz ist das. Und hier sind die ganzen Mahlsteine und die ganzen kleinen Geräte. Und da liegt die Erze aus Saktrice auch. Das ist jetzt hier so ein Stück, kann man so nicht so gut erkennen, aber es war so hier gewesen jetzt, ja. Deswegen, da sind ja wir hier, die weitergekommen sind, und dazu überall treffen wir die Fragmente von Tiegel. Tiegelfragmente, die wird ja doch als für unterschiedliche also Metalle geschmolzen wurde hier, wie Kupfer, Silber und auch Gold auch, ja. Und deswegen hier haben wir auch einen Arbeitsplatz, wo die Saktrice Golderz wurde bearbeitet. Das bedeutet, die Saktrice Golderz ist eine hämatithaltig, und es wird die Hämatit so verteilt. Also da in diese also Keramikschüsseln wurde die Pigment, die rote Pigment getrennt aufbewahrt. Ja. Und deswegen, das sind jetzt die Sachen, was wir jetzt zurzeit in unserer Forschung weiter laufen wird. Und hier haben wir das ist die ganze große Schicht von der eisenzeitlichen Besiedlung, riesengroßes Besiedlung ist das. Und da unten kommt die Kuraxis die ist ganz zerstört, fast von der eisenzeitlichen Gruben. Und da unten sind die chalkolithische Gruben. Da ist die chalkolithische Grube hier und das ist die Kuraraxis und da oben ist Eisenzeit. Also, und da ist eine kleine Tiegelchen rausgekommen und die Tiegel, der trägt so in dem, also nach dem Forschungsanteil, also Forschungen wurde dort die Silberanteile gefunden, deswegen der Saktrisi Golderz wird sehr viel, also bis zum 25% Silbergehalt haben, ja, und konnte das sein, das wird hier so auch so die Spuren davon gewesen wurde. Und jetzt haben wir eine ganze Menge so Arbeit hier. Das ist ein Malplatz oder Pochplatz oder das ist eine ganze Menge Pochsteinen und so Platten drauf. Und hier wurde die Erde hier rausgenommen und das wird gewaschen. Und zu diesem Platz hier so wurde die ganze also Tiegelfragmente gefunden. Also es sind noch mehr, also das sind so also die Dutzende von diesen Fragmente. Und hier wurde also von diesem, das ist die Goldanteil trägt diese Erde hier. Da draußen wurde auch die ganze Erde gewaschen, aber da sind keine Nachweise von den Goldspuren. Ja. Und das ist jetzt im 2021. die letzte Grabung. Also das war dieses Haus, was ich jetzt gezeigt habe. Und hier wurde also die Goldspuren gefunden. Und dann haben wir hier noch die weitere, so eine riesengroße, also so eine Plätze, die sind auch so mit dem Arbeitssteinen so ganze Menge. Und hier kommen überall, das sind die Kindergräber, das sind noch kleine Kindsgräber. Das sind überall so kleine Kindsgräber. Also wir vermuten, das musste eigentlich ein Ritus sein. Ja, also kann sein, bei dem bergmännische Arbeit, weiß ich nicht, aber trotzdem überall, da sieht man diese kleinen Gräber hier. Und dazu sind, naja, das ist hier gefunden, diese Kupfer, ist Tiegelfragmente, das ist von dem Jansen jetzt erforscht und das gibt es noch hier die neuen Nachweise, dass wir hier so diese Objekte jetzt hier so Goldgehalt haben und in letztes Jahr wurde hier so in diese kleine Grube als kleine Werkstatt bezeichnet ist und da ist eine Goldtiegel und diese Goldtiegel wurde in Tiflis im Nationalmuseum so eine Aufnahme gemacht und die sind ja so kleine Körnchen, kann man auch gut sehen zurzeit. Ist diese Tiegelfragmente in Bochum und der wird ja doch in nächste Zeit ja, mikroskopisch untersucht. Also das sind die Haus 4. Was wir jetzt hier haben, das sind die ganz wichtige Fundplatz. Das ist diese pigmenthaltige und die ist ganz neben von diesen Gruben. Und jetzt haben wir hier eine Waschpfanne, weil in dieser Waschpfanne und das ist eine Herdstelle und da steht hier eine, also so ganz besondere kleine Schüssel. Und die Schüssel war voll mit dem goldhaltigen also Erde. Da wurde bis zum 6,5 ppm Gold reingefunden wurde. Und wir vermuten, dass diese Schüssel musste eigentlich so auch die goldhaltige Erde waren drin. Und alles diese also Nachweise, wir haben jetzt in Forschung, also jetzt wollte ich nur das jetzt sagen. Das ist jetzt die weitere Area 3.5 in Balici-Zezwebi. Und hier wurde auch so eine also Werkstattartiges gefunden, die war zerstört, aber trotzdem, da gibt es ganze Menge, also Kupfer, Arsenikmetalle, so also die kleinen Stücke, so ganze Erzen, aber es gibt auch die Tigerfragmente und die wurde so untersucht und wir können das hier so gut sehen, was das hier los ist. Ja. Und ja, das ist jetzt in diesem Jahr, in 2021, haben wir weitere Haus ausgemacht und hier können Sie gut sehen, wie viele Arbeitssteine hier umliegen und hier in diesem Stück wurde hier auch die Tiegel auch gefunden, Tiegelfragmente und das ist also so eine Platte, so eine große Platte, da unten liegt auch noch eine und deswegen die ganze komplexe Betrieb davon, das sind hier wird ja die Erze bearbeitet. Ja. Es gibt so viel zu tun, also in diese Richtungen, jetzt was wir jetzt dort haben. Jetzt, was haben wir jetzt? Produkte, ja, die Gold und Silber in Georgien. Ja. Die Silber, also die Gold, früheste Gold taucht in Georgien in Sachere, das ist also Kuraraxis so Siedlung und da in die Kurgane und die kommen die zwei so Ohrringe, dazu sind, wo sind die, das weiß ich. Ah, okay, gut. Ja, und das sind die Ohrringe und dazu haben wir jetzt hier erst die Silber, werde ich jetzt über Silber irgendwo meine Folie ist irgendwo verschoben, ich glaube, weil ich wollte das zeigen. Und hier gibt es so die ersten Nachweise, das ist Kuraraxis-Siedlungsmaterial. Das kommt in Kuraraxis kommen die Zinn, Silber und auch den Blei. Auch. Es gibt auch die Bleibaren auch, ja, in Amiralis Gora, dazu auch die silberne, diese Ringe hier. Und dazu noch in der Kurgane tauchen sehr viele Objekte, das sind die Silberobjekte zusammen, die sind eine Weinräber. Das sind die Weinräber, die sind auch reingesetzt und extra, das ist derselbe, das habe ich jetzt vergrößert. Und es gibt einen Dolch hier, so eine Dolch, da ist ja doch eine silberne und da gibt es auch die ganzen Nachweise, das Silber wird hier auch so im 3. Jahrtausend kommt schon vor. Und dazu sind auch diese silbernen Ringe hier aus Sachere und dieses Bracelet aus Ananaure und das ist jetzt die Vergleichsmaterial aus Aslan-Tepe. Und Aslan-Tepe ist ja sehr gut erforscht und damit die ganze Menge dieser Objekte jetzt zusammen, also ist auch was gehört zum einen der Kultur, Kuraraxis-Kultur. Ja, und das sind die Goldobjekte hier, das ist die Sachere, ganz früheste Goldobjekte, also das ist die aus Koreti, so erste Hälfte 3. Jahrtausend und dann kommt die von Irganchai und auch von Sachere. Also das sieht man auch so im 3. Jahrtausend in Westgeorgien gibt es so eine Kuraraxis-Gräber und also das sind auch so mit den Goldohrringen auch so und die Paravani und deswegen da gibt es eine ganz gute Publikation von uns. Jetzt gerade ist erschienen, endlich der Tagungsband von in Tbilisi in 2016, endlich ist rausgekommen. Und da sind ja da alles publiziert. Und das ist jetzt die Nachweise, was für eine Goldobjekte jetzt in Georgien für 3. Jahrtausend zusammen sind. Das ist jetzt der Kurgan, die wurde in also 2015 wurde die wurde ausgegraben, riesengroßer Kurgan in Ananauri. Und da wurde die ganze Menge wunderbare Objekte und die ist auch sehr gut datiert, ist datiert nach Mitte drittes Jahrtausend und auch die mit dem Goldobjekte dazu, ja. Das ist unsere wunderschöne Löwe und die Löwe, wenn Sie nichts in Hand gehabt haben, davon unten, die ist hohl. Und da sind auch die ist da wie ein Aufsatz. Es musste auch ein Aufsatz sein vom also Wagenaufsatz und mit seinen Geschlechtsorganen hier, so die sind so dargestellt. Ja, das ist jetzt zusammen alles und da kommen wir in zweites Jahrtausend. Die tauchen bei Trialeti-Kultur jetzt die ganze Menge also Goldobjekte und das habe ich jetzt nur Details hier so, aber der Herr Jansen, wenn er so eine schöne Vortrag konnte halten, das wäre natürlich schön, weil er hat die ganzen Objekte untersucht und eigentlich das sind die sehr gut dokumentiert. Ja. Ich glaube schon, da bin ich sehr fertig und dann, ich bedanke mich ganz herzlich. Danke.
Running a little bit behind schedule. We could maybe Gwen give a very short summary of a kind of very wide-ranging talk, quite difficult to summarize.
I will try to do it justice, but probably I won't manage to, so I will be very short. So Irina gave us an overview of metallurgical activities from the 5th millennium BC to the Iron Age, not only in Georgia, but she also touched on evidence from the wider Caucasus and made connections with the Near East or adjacent areas, such as Anatolia and Iran. Georgia and the Caucasus is very rich in ore deposits such as copper, iron, lead, antimony, zinc, and other metals. She discussed various objects from between the 5th millennium BC and the Iron Age, covering those specific deposits. She also, a big part of our presentation was about gold and silver objects, specifically in Georgia. Then the earliest evidence for the use of copper ores in Georgia comes from the late Neolithic and is dated to 5,800 to 5,300 BC. And also she also touched upon the research history of the mining museum in Bochum and German collaborations in the study of early metallurgy in the Caucasus. Yeah, that's it.
Thanks very much. Perhaps we can turn now to Dr. Khachatur Meliksetian from the Institute of Geological Sciences in the Armenian National Academy of Sciences, who will give us an overview of prehistoric metallurgy in Armenia to complement Dr. Gambashidze's talk focusing primarily on Georgia.
Yes. Thank you for the introduction, Nathaniel. So I will now share my screen. So first of all, I would like to thank conference organizers for this opportunity and for inviting me. Thank you very much. So in this presentation, I will summarize results of long-term collaboration of Institute of Geological Sciences of Armenian Academy of Sciences with Armenian archaeologists, first of all with the Institute of Archaeology and Ethnography of Academy of Sciences and archaeologists representing Ministry of Culture and Museums in Armenia. And this collaboration was with Kurt Engelhorn Center for Archaeometry in Mannheim, Germany, led by Professor Ernst Pernitzka. And we have more than 20 years of collaboration. Altogether, more than 500 archaeological objects were analyzed for chemical compositions, for isotopes, and more than 20 papers were published in the last 2 decades. So this is a short overview of periodization, case sites, and chemical groups of studied artifacts. So as we see that metal finds in Armenia cover all significant phases of prehistoric metallurgy. First is Neolithic use of early use of copper, then pure or native copper, then in Neolithic is or Chalcolithic is marked by transition to extractive metallurgy, and then early Bronze Age is remarkable with wide use of copper arsenic and some other alloys and early appearance of tin bronzes, while in Middle and Late Bronze Ages the number of types of alloys significantly increase, and there are some pieces and alloys that proves that some advanced metallurgy and alloying existed in Middle and Late Bronze Age, and also some pure metals were also used like antimony, tin, and lead. So the earliest phase of use of copper is in Armenia is marked by azurite and malachite finds in Akhnashen, in Neolithic site of Akhnashen, and copper bracelet find in Aratashen. These two sites are nearby and both were excavated by Armenian-French expedition led by Ruben Badalian and Christine Chardenier. So this copper bracelet was analyzed in Germany, and it turned out that this pure copper, and we interpreted it as a native copper. So it is copper that people at Neolithic times were able to find a deposit, but native copper is relatively rare. So it is very interesting that at that times people were able to find this native copper and use it for making decorative objects. So these objects from site of Nerkin Godedzor that represent arsenical copper with 4 to 5% of arsenic mark this transition to extractive metallurgy, because this composition can be only achieved by smelting. And then these are few examples of metal objects representing early Bronze Age Kura Araxes culture. And as we see, this necklace of Gerarod, that is a famous archaeological find, is interesting by its composition. I will stop on it in more detail on further slides. These are metal artifacts and molds from Shengavit, again representing Kura Araxes culture. We see also that gold was used in Kura Araxes, but there are very few objects made of gold. And of particular importance is early tin bronze from Tallinn, from tomb 11 of Tallinn. This is one of the earliest tin bronzes known in South Caucasus. It contains 11% of tin. And as we will see further, the isotopic composition of this object is very interesting and provides some interesting data about possible sources of this tin bronze. For early Bronze Age, as I mentioned, so it is wide use of copper arsenic alloys is typical, and as we see in the statistical diagram, so 75% of objects were made using copper arsenic alloys, and we see relative enrichment of arsenic in artifacts relative to ores. And this data comes to say that decorative objects and samples from crucibles, copper samples from crucibles, are enriched in arsenic, while tools and weapons usually contain less than 3% of arsenic. This is because high concentration of arsenic makes the alloy or the metal brittle, and it is not good for tools and weapons. While in case of decorative objects, it is an advantage that ancient smelters were able to produce alloys with different colors to emphasize this artistic value of this object and so on. So we see that different by the example of necklace from Gerarot, we see that different types of beads were made by using different alloys. And this all comes to say that arsenic, because this question was debated for a long time, but this data, statistical data, and this data clearly proved that this alloying with arsenic was intentional. So people knew what they are doing, and they produced, they used alloying with arsenic to produce metals or alloys or artifacts with different colors, from silvery to dark gray shining metal, or to copper red if it is pure copper, or to yellow in case of copper, arsenic, lead alloys. So many of these types of beads and these ones are actually yellow, but not in these artifacts, just lead and arsenic. These are deposits of the region. So there are many copper and polymetallic ores in the region, gold ores, silver ores, copper ores, but actually no economically significant tin ores. So geochemically, it's very important. In many deposits, geochemically, tin present as a impurity, geochemical impurity in major sulfides, as in quantity of few dozens ppm, but from there is no data that this tin can be extracted from the ores. And this is a more focused view on Armenian ore deposits. So there are 3 metallogenic provinces, depending on geological terrains in Armenia. And also this map shows the locations of archaeological finds. So in most cases, we see that most of these archaeological sites are relatively far from sources of copper that are mostly in north, east, and in south Armenia. So the ores were transported and smelted at these sites. So this provides a good evidence for early and middle Bronze Age metal extraction and trade of metals in the region. We applied a lead isotope analysis for both ores and artifacts to find some similarities and attempt to trace the metal back to their ore sources. And it turned out that Armenian copper ores are characterized by very complex lead isotope signatures. But nevertheless, when we compare this with the lead isotope compositions of artifacts, we see clear correlation between most of the artifacts, these are red cycles, with local ores. We call local ores so far analyzed in South Caucasus and in Anatolia. So the sources partly overlap, but there is still a very good correlation, which obviously means that local copper was used and utilized in early Bronze Age. But also we found some artifacts that are outside these local fields, and so obviously they were imported from other locations. So Middle and Late Bronze Ages in Armenia are marked by transition to advanced metallurgy and alloying in Middle and Late Bronze Ages. So number of types of alloy increase. We see appearance of copper tin alloys, copper tin arsenic, early brass objects, copper, arsenic, and lead alloys, and pure antimony, which is also specific to the use of pure antimony is specific to South Caucasus. And there are thousands of pure antimony objects in Armenia, Georgia, and Azerbaijan, but in other regions, only few objects are known. And the same for Late Bronze Age, but in Late Bronze Age, widespread appearance of tin objects, pure tin objects, is also very important and interesting. And in Late Bronze Age, there's also some interesting alloys like copper, antimony, and lead, or copper and antimony. These are some artifacts analyzed in last decades, representing Middle Bronze Age and the Late Bronze Age. Or more artifacts from Late Bronze Age. And when we analyze chemical groups, we see that most of the artifacts were made of copper and tin alloys or tin bronzes, considering also some admixture of arsenics altogether. About 60% of objects were made with alloyed with tin. And a similar picture is also can be observed for a Late Bronze Age. When we compare arsenic content in early Bronze Age with statistical distribution of arsenic alloys in Middle and Late Bronze Age, we see that the picture is completely different. Here we have a big number of artifacts with arsenic content of more than 3% in early Bronze Age, while in Middle and Late Bronze Age, in most cases, we have less than 1% or less than 2% of arsenic. And this holds true both for tools and weapons and for decorative objects. We also selected some chemical groups based on nickel and silver content because there are some high nickel and silver alloys that are not typical for local ores, and this indicates some imported alloys. And compared to early Bronze Age, Middle Bronze Age artifacts are in better, let's say, agreement with local ores considering their arsenic content. So no intentional alloying with arsenic can be observed in most cases, but some natural admixture of arsenic that comes from ores. Of particular interests are these bimetal objects found in royal tombs of Loribert by archaeologist Seda Devejan. These are really unique objects that are made of two types of metal. So one is yellow tin bronze with typical tin bronze with 9% to 10% of tin, but there is also black shining metal that turned out to be copper arsenic alloy with up to 28% of arsenic. This is so far the highest concentration of arsenic in metals of prehistoric times. And this obviously means, again, that it is intentional because ancient craftsmen made these bimetal objects. And also maybe it also means that this knowledge of producing high arsenic alloys was either preserved until the Late Bronze Age or maybe reinvented again in Late Bronze Age. but still we have here, in case of this object, some similarities with the necklace of Gerarot, where again some dark gray metal turned out to be copper arsenic alloy. And when we consider isotopes of the Middle and Late Bronze Age and compare them to Early Bronze Age, again, we see that most of the artifacts are located in the field of Armenian and Anatolian ores, which means that they come from the local ore sources. But still we have some unusual lead isotope signatures for some artifacts that are probably, not probably, this means that some metal objects were imported from other locations. And it is very also interesting to note, yes, and this is some antimony objects that I presented earlier, lead object from late Bronze Age, and tin objects from Lechashen. And I would like to stop on tin in more details, because, for instance, in Lechashen there are about 12 tin objects found in recent excavations. And some part of them we could analyze. But in Metsamor, there are thousands of tin objects. It's really unbelievable how many tin objects were excavated in last decades from what single archaeological site in Metsamor to thousands. And we analyzed recently 100 of them, and most of them are pure tin. Some objects are tin lead alloys, but lead is usually less than 5%. And there are also only 2 tin lead antimony alloys. So most of these artifacts are represent pure tin. When we talk about tin, it is very important to mention that neither in South Caucasus or Anatolia, no tin source exists. The tin source that could be used in antiquity, a deposit where tin appear in a form of cassiterite that is extractable, because if tin is impurity in pyrite or in other sulfides, it is not possible to extract it, especially using the early Bronze Age or anyway prehistoric tools and these methods. While the gold, for instance, is possible to extract. So the problem of tin origin and its trade is a special issue for the history and archaeology of the ancient Near East during 3rd and 2nd millennia BC. And it is important to mention that tin is mentioned in Near Eastern written sources since the 3rd millennium BC as anakum. And also, sometimes it is interpreted as the land of tin, with the name anakum. And according to other viewpoints, anakum, maybe it is lead with the corresponding mines in the Urmia region or arsenic bronze. But it is very important evidence of one of the regional languages, the Armenian language, where anak means just tin. And this demonstrates that possibly the name under consideration could really designate tin. And the term anak in Armenian is usually interpreted as adopted from ancient Near Eastern languages. And so in case of Metsamor, we really think that maybe it was a tin trade hub in South Caucasus, because it's really unique archaeological site with so many tin objects. And what lead isotopes may tell us about origin of tin bronzes. First of all, it is important to mention that if we have tin bronze, then lead isotopes are mostly demonstrate the source of copper rather than one of tin, because usually tin ores are very pure, are very poor in lead, but the copper ores are, in contrary, usually rich in lead. And so for early Bronze Age, for these rare tin bronzes that we analyzed from early Bronze Age, we have, for two of them, we have unusual high lead isotopes. So these are these red circles here. And this large field is field of early Bronze Age the tin bronzes, lead isotopes of tin bronzes from Troy, Mediterranean, Anatolia, Persian Gulf, and Dagestan. It's after Lloyd Weeks and others. So we see that two of Armenian Middle Bronze Age tin bronzes, one late Bronze Age object, and two early Bronze Age objects plot in this field. But while all other Middle Bronze Age and Late Bronze Age tin bronzes are within the same Armenian or Anatolian local ores lead isotope field. This leads us to conclusions that some objects in early Bronze Age were imported from unknown location, and while in Middle and Late Bronze Age, local copper was alloyed with imported tin. This is an important conclusion that we can make from this lead isotope diagram. And also the now application of tin isotopes, it's a new, relatively new revolutionary method, and the lead isotopes of tin objects is in progress. So these diagrams are new. I just got them a few days ago. So I have nothing more to say about this, but this is very important research that is currently in progress. And also considering limitations of the method, tin isotopes allow not to trace the provenance of tin, but they can help to exclude some tin sources. So it's a little bit different compared to lead isotopes. So on conclusions, so early use of native copper in early 6th millennium BC and early extractive metallurgy, late 5th millennium BC, are evident in the territory of Armenia. Early Bronze Age is marked by widespread use of arsenical copper, unalloyed copper, rare tin bronzes, and some other alloys. Some objects extremely high in arsenic provide evidence of advanced alloying technologies. The majority of analyzed artifacts could be smelted from local ore sources abundant in the territories of Armenia and Eastern Turkey. In Middle Bronze Age and Late Bronze Age, the number of alloys used increased. Early brass appeared in Middle Bronze Age. Unalloyed tin and antimony were also used. Alloys extremely high in arsenic, up to 28% of arsenic, are still present in some extraordinary decorative objects and artifacts. Some of the artifacts high in nickel and silver exhibit unusual lead isotope signature, not typical for local ores, and were most likely imported possibly from Oman. Early Bronze Age tin bronze from Tallinn exhibits lead isotope signature typical for most of the other 3rd millennium tin bronzes, signifying origin of early tin bronze from unknown copper tin ore source that is presumably of Proterozoic, early Paleozoic age. This is also very important because there are Proterozoic and early Paleozoic rocks. This is geological age in Armenia and in South Caucasus and in Eastern Turkey, in Anatolia, but no mineralization exists in Proterozoic and Paleozoic rocks. So these unusual lead isotopes come from different region with different geology, where Proterozoic to Paleozoic ore deposits, including tin ores, exist. This is very important conclusion based on the data we have. In Middle Bronze Age and Late Bronze Age, tin bronzes exhibit lead isotope fingerprints typical for local ores, with just few exceptions, suggesting that in Middle Bronze and Late Bronze, local copper was alloyed with imported tin. And because lead isotopes of bronzes mostly inherit those of copper sources rather than tin sources. So I would like to gratefully acknowledge our friends and colleagues from Kurt Engelkort Center for Archaeometry in Mannheim, Germany, for great help and assistance. And special thanks to Institute of Archaeology and Ethnography for long-term collaboration and providing samples of artifacts. Thank you for your attention.
Thanks very much, Khachatur. Really interesting results, especially with those. Glad to see the new work on tin isotopes being applied to these kind of pure tin objects.
Yes, yes.
Really fascinating work. If I could ask folks to maybe put your questions into the chat so we can not fall too far behind schedule, and maybe Khachatur, if you can maybe answer the questions in the chat. And Irina, if you noticed, there was a question for you that showed up in the chat during the talk. So if you could take a look at that, that would be fantastic. But it's time now to turn to our last speaker, Dr. René Kunze, who's going to be talking about a new project, or I guess a project that has received a kind of new influx of funding, shall we say. The project Ushkiani, looking at gold and gold sources in the South Caucasus. So please, the floor is yours.
First of all, thank you very much for the invitation. And yeah, okay, let's start with the Ushkiani project. The following talk provides an overview of the results of an Armenian-German joint project in Eastern Armenia, with a special focus to preliminary results of gold analysis. Since 2010, interdisciplinary investigations regarding gold mines and their archaeological context are carried out. So, for that purpose, the area to the southeast and north of Lake Sevan in the Gekarunic province has suitable conditions for these investigations. It provides many indicators for prehistoric settlement structures within this clearly defined landscape. This landscape stretches along an important supra-regional communication and trade route and is in proximity to possible sites of prehistoric gold extraction. Our archaeological investigations have demonstrated that these topographical peculiarities have been used by the local inhabitants since prehistoric times. Until today, we were able to map and document 94 sites, of which 68 were previously unknown. Most of them were populated during the early to late Bronze Ages. Besides several investigated graves from the transition from the 2nd to 1st millennia BC, so the late Bronze and early Iron Age, the site of Artanich 9 is of particular interest. Here it can be stated that the entire settlement mound probably represents a single-phase settlement from the early Bronze Age. In addition to typical installations within the buildings, such as hearths made of clay, as well as typical pottery, all C14 results from bone and charcoal material represents a site of the late phase of the early Bronze Age. That is unique in the region so far. So far, however, no clear evidence could be found that the Bronze Age settlement activity in the region was directly related to the exploitation of the gold deposits. However, the surroundings have great archaeological potential, and the circumstances of the local geology and the natural mineral deposits of the native gold, as well as the quantity and the spatial distribution of placer gold within the river sediments, confirm the possibility of a prehistoric extraction of primary and secondary gold in the region. In this framework, the current public debate is interesting. There is the assumption that maybe the resource gold was the reason for the Urartian conquest of the region under the reign of Saturi II in the 8th century BC. The rock inscriptions of Sovak and Invan could point to it. But before presenting, before presenting first results of gold analysis, I want to discuss the different aspects of gold and the question why we do chemical analysis on gold at all. The reason for this is because I experienced that I was usually confronted with the same questions by the archaeologists or museums curators when they are confronted with chemical analysis on their gold finds. So we must be well aware of what we want to achieve or what is at all possible to achieve by the applied chemical analysis. For other materials, so for example, for copper, ceramics, or flint, certain methodologies could already be established, and the archaeological and geological framework also has been researched systematically over a bigger time span. But with gold, we are more or less still in the initial stages of this process. And this is something we have to be aware of from both sides, the natural scientific and the archaeological one. Chemical analysis on archaeological artifacts always have to be scientifically justifiable, because often samples have to be taken and the objects are damaged by this. So if we want to analyze gold objects, we have to give good explanations for that, as you can imagine. Nevertheless, the demand for chemical gold analysis within archaeology grew steadily in the last decades, what can be ascribed mostly to the growing analytical possibilities. Especially the developments in laser ablation, inductively coupled plasma mass spectrometry, the LRICPMS, made a nearly non-destructive analysis up to the trace elemental range possible. So it appeared convincing that it should be possible now to uncover prehistoric gold sources in a similar way as it happened for copper, for example. What we are mostly dealing with in archaeological science are the objects, so the products of all the processes involved in this workflow. But since some years, a special effort is also being made in the geochemical characterization of primary deposits or lode gold and secondary occurrences or placer gold from different regions of archaeological interest. Concerning the methodological problem of the comparison of natural unprocessed gold with artifact gold, on this slide, I have summarized some aspects of the geochemistry of gold. Basically, gold occurs in two types of deposits: primary deposits or lode gold and secondary deposits or placer gold. Their composition is influenced by various factors as pointed out on the slide. These are basically due to the different formation processes and the geological surrounding. Placer deposits in particular are additionally often linked to occurrences of other mineralizations than gold that all have an influence on the final composition of the gold that is being penned out of the rivers. As a conclusion, we can find numerous factors that influence and alter the chemical composition of the gold, especially the placer gold, that are just to small extent reconstructible. Taking into account now the other side of the chain operatoire, namely the artifacts, again, chemical alterations happen that are connected to the metallurgical processes the gold has to pass. As in copper, some elements that might be characteristic for the geological source are volatile and decrease or disappear during the heat treatment. Additionally, one has to reckon with contamination and mixing of different raw gold during the fabrication processes or even alloying. All this amplifies the uncertainties of chemical alterations of the gold and thus hinders provenance studies. But now let's go back to our project in Armenia. In the region of the Eastern Gigarunic province, there are two gold occurrences: Sotk, with its current gold mine in the east, and the gold occurrence of Zarazar in the south. Within an ophiolite complex, the Sotk deposit is a fault-related epithermal gold-dominated polymetallic occurrence in veins. The gold-bearing quartz calcite veins crop up over wide distances of several kilometers. The width of the ore veins varies between a few centimeters up to 50 meters. The average gold content ranged from 2 up to 30 grams per ton and partly more than 300 grams in the oxidation zone. The gold mineralization is dominated by visible free gold and gold tellurides with a grain size up to 3 millimeters. The mineral paragenesis also contains minor strata of different copper, lead, and zinc minerals. Massive secondary copper minerals have been proven in some parts of the deposit. A total of 43 rivers and brooks were tested to determine the quantity of placer gold. In 25 rivers, placer gold could be found. The placers are spatially concentrated and correlated with the outcropping mineralized veins. In particular, the main streams and their tributaries, which are situated close to the aforementioned deposits, have shown high contents of placer gold. Due to the mechanical transport, placer gold has often hardly reproducible influences on the geochemical fingerprint and numerous different trace element contents in relation to the primary gold. Based on our geochemical investigations of more than 70 samples of placer gold and some primary gold, fortunately for us, the trace element patterns showed that the gold is more or less very pure and comparable with the primary deposit. Regarding to their main elements, we can also differentiate the gold from our two gold deposits. The specific elements which allow a clear differentiation between the various local deposits Sotk and Zarazar are their gold-silver and gold-copper ratios, and some difference in contents of cobalt, nickel, bismuth, and antimony. These elements are particularly stable in the face of both metallurgical and geological processes, and therefore are potentially useful for provenance analysis of gold artifacts in the following step. On this slide, you can see some of the archaeological find spots with many documented gold finds. So we hope until the end of the project, we will have a good overview about the chemical composition of prehistoric gold finds. On the basis of the 40 gold objects examined so far, it could be determined that almost all of them can be characterized as alluvial gold. The overall high contents of tin, but also the regularly higher concentrations of platinum and partly palladium, point quite clearly to the use of secondary gold from placers for artifact production. Of course, this is not surprising due to the numerous gold-bearing rivers in northern and eastern Armenia, as well as the adjacent southern Georgia. An exception is the studied spiral rings from Goraik, here from the southern part of Armenia, where there are clear indicators of the use of rock gold. This object is also the oldest objects we have for our investigations from the mid of 3rd millennia BC. The Mount Grape, the so-called Big Kurgan at the Goraik site, which was investigated by Jakob Simonian in 2020 and dates to the early Middle Bronze Age, is only about 5 kilometers away from another gold deposit at Gora Kizir, so that the provenance of the gold from this site can be assumed. With 3 exceptions, all examined samples consist of electrons, so a gold-silver alloy with silver contents with more than 25% of silver. It could be proven by the lead-silver ratios that the silver of the object must originate from a deposit with natural gold-silver alloy and was not intentionally added by cupellation. Cupellation from silver-bearing lead ores to extract silver is the only known process in prehistory, as it was also demonstrated in the example of 2 silver objects from Loribert within the project. A silver content in these dimensions, so up to 49 weight%, is rather rare and should be valued and discussed as the only geochemical fingerprint so far, since very likely all other elements rather entered the artifacts through metallurgical processing. Thus, this represents an excellent indicator to draw conclusions on possible occurrences. The deposits of Dilijan, Margarovit, Violetovo in the northern part of Armenia and Sotk, which were investigated during the preliminary work, are therefore not be assumed as origin of the gold. However, at DMF, so Dilijan, Margarovit, Violetovo, it should be noted that the statistical base of only 3 analyzed placer gold samples is very small, but the trend is evident. At Sotk, the number of investigated placer gold is much higher and shows a rather homogeneous silver ratio around 10 weight%, which is comparable to the primary gold with about 9% silver of the deposits, and thus much lower than the silver content of the investigated objects. In contrast, the Zarazar deposit is of particular interest. The already described deposit southwest of the Sotk district, with its main tributaries Masrik and Gemajai, shows very comparable silver contents as in the objects and seems to make an origin from deposits of the genesis possible, without clearly committing to the singular occurrence Zarazar at this point of time. In addition to Sotk, Zarazar, and Dilijan Margarovit, spatially adjacent gold deposits in Georgia must also be considered. So recently presented results by Maurice Janssen show that neither the rock gold of Saktrisi nor alluvial gold from the Great Caucasus is comparable with respect to natural silver contents. According to the evaluation of the previous results, the copper content of the investigated finds is not suitable for a search for the raw material base or deposit. It could be shown that in almost all cases, the copper content of the objects is many times higher than in all gold deposits known so far. So that means that copper was intentionally added to most of the objects, since a polymetallic composition of the objects could be excluded by microscopy. Also, copper is unrestrictedly soluble in the melt in any ratio. So some examined samples, for example here this bead, show that from the originally homogeneous alloy, so the homogeneous solid solution, a biphasic microstructure is present. In order to answer the question of the reason for the intentional addition of copper to gold, several hypotheses can be put forward, which I will not go into detail now. However, The synthesis of the hypothesis shows that the intentional addition of copper was intended not only to change, for example, the color intentionally, but also to increase the hardness. So maybe as a conclusion, or in summary, it can be stated that there is, in my opinion, a clear limitation in the mapping between object and raw material, as far as one refers exclusively to the main and trace elements. But nevertheless, it is possible to achieve this goal with the help of a lot of other investigations, such as metallographic investigations, the knowledge of the geological background of the deposits, and the use of lead isotopes, provided that it can be assumed that there was no gold mixing, which of course is very, very likely in the objects from the 2nd to 1st millennia BC. Thank you very much for your attention.
Thank you very much. That's a really interesting project, and congratulations on the recent influx of funding. And so, yeah, very excited to see this project develop further and interesting. I wondered if I might ask, like, with the issue of lead isotopes, if you have copper being added, even in relatively small amount, does that, I mean, would this lead isotope signature of the gold be reflective of the lead from the added copper relative to the gold? Because I mean, what's the range of gold content lead content in gold generally?
Generally between in the gold objects, you mean? Or?
Yeah, well,
yeah.
Like in alluvial gold, like So is the if you add like 5% of copper into a gold object, will the will the lead that copper that you add swamp the gold signal in the gold deposit itself?
Yeah. In the object, I think it's the copper content is 400 until 800 times higher than in the deposits of the gold.
Okay.
So we have in the objects between 2, but very, very often between 6 and 8% weight. I think the highest is a bead with 9% of copper.
Mm-hmm. Okay, so yeah, so then in that case, the lead signal will be showing the source of the copper, not the gold.
Mm.
Yeah. Interesting. So I would like to kind of open up the floor a little bit to kind of some more discussion of these kinds of talks. I think we've seen a real kind of range of research from discussions of production sites at Sakdrisi and elsewhere, and extensive analyses on metal artifacts and everything from chemistry to isotopes, and a great sort of combination of field work and lab work. And I think what would, if there was one thing that I was would draw out of all of these, is that to answer these questions about ancient metallurgy, you need to have really robust integration between the field and the lab. It goes to sort of these interesting discussions about tin and whether there are some tin deposits in the Caucasus. It doesn't necessarily mean just because you find one some evidence of local tin doesn't necessarily mean that there were more extensive supplies being imported in other parts. So I think like piecing out these kinds of things requires a really strong integration between field work and lab work. And I think another really strong feature of all of these talks is a really evidence of robust, extended, in many cases, decades-long collaborations between foreign archaeologists and scientists and local archaeologists and scientists. And I think this is a really interesting and positive development, I think, that really does justice to the kind of, and is quite an interesting evolution in terms of the grand scope of the field from earlier periods, and is a good way to kind of move the field forward. So it's really quite exciting to see these projects now, many of them entering their second or third decade of collaboration. But I want to kind of open it up a little bit to some broader discussions or thoughts about that folks have about this. So please raise your hand or add something to the chat, and I'll be happy to call on you. Bertilione, please unmute yourself.
Yes, I'm sorry. I'm just surprised. I mean, Irina, I asked her a question, but maybe she didn't understand because it is in English. I'm surprised. I mean, with all these gold objects that we have from the early Bronze Age and after, how many do we have that we are sure are coming from the Sackgrissy mines? Are they all, like René Kunze just said, rather from placer gold? So that means, where would all this gold from the Sackgrissy mine, where was it going? Do you have an answer?
Irina, I believe you're still muted.
Ja, okay. Can I in Germany? Also die Sackgrissy Gold, leider können wir die georgische Goldobjekte nicht Proben nehmen. Das ist bei uns verboten. Deswegen, wir haben für so eine Bleisotropie keine Möglichkeit, die georgische Goldobjekte zu Proben rauszukriegen. Das war das ganze große Problem bis jetzt, aber Herr Jansen kann dafür so die einigermaßen, so, das ist auch publiziert, die Hassansu-Goldobjekte gehören, also da ist ja doch eine der die aus Sackgrissy zustimmt, mit dem Geochemie auch und mit dem Bleisotropie auch. Ja. Deswegen, wir versuchen, also zurzeit bei uns ist es sehr schwer, diese Goldproben zu nehmen, also weil irgendwas ist fast unmöglich. Ja. Zurzeit hat Herr Stöllner in Aslan-Tepe so mit dem zusammen mit Jansen so eine Probe von diesen Goldobjekten aus dem Fürstengrab rausgenommen, und die wird ja in nächster als also nicht für die Bleisotropie, da kann man nicht so abzapfen irgendwas, ja. Deswegen, also da, wie ich das weiß, das ist eben also Berggold bezeichnet. Das ist kein alluviales Gold, ja. Das sind die irgendwie. Aber was wir jetzt haben, das ist in Choraxis, gibt es also in Sachere-Gräber, das ist die Choraxis-zeitliche Gräber, die sind auch aus also so Gold, da können wir das auch nicht Proben nehmen. Das ist das große Problem. Erste Problem. Einzige, was wir jetzt bekommen haben, das war von Hassansu, also Grabsfunde wurde da auch publiziert, und das wurde auch analysiert, und die ist die einzige, was wir jetzt die Sackgrissy Gold gefunden haben.
Okay, thank you, Gwen, for providing some real-time translation of the answer. Thank you. Khachatur, did I see that you had a comment, or did you raise your hand earlier?
Just a moment. Yes, thank you. So I have a question to Irina. So first of all analysis of gold objects archaeological gold objects published in literature? If yes, would you please send us, because we are going to compare all the for our Ushkiani project that was presented by René, we are going to compare all the archaeological gold objects analysis with our data on archaeological and geological gold samples. So as for gold from Sagdrisi, I know that you published the data. This analysis of geological gold samples are available, and we reference this data. Thank you.
Ja, also jetzt ist zurzeit neues Buch erschienen, das ist dies hier. Da haben wir hier diese Publikation, das war in Tiflis, war so eine Tagung in 2016, und das ist also Beiträge sind auch dazu, also da sind auch die ganze Menge Publikationen sind ganz frisch und neu. Also was bedeutet neu? Also seit 2016 sind viele Proben, aber von Gold können wir aus Nationalmuseum keine Goldproben bekommen. Das leider ist so.
Okay, thank you.
Ja.
Okay. If there's Magda has a comment or a question.
Yeah, I have a question to Dr. Irina. Like, I was curious, the crucible fragments from the Araujo, like you mentioned, it is Chalcolithic time, and there is some analytical investigation, some analysis, or some publication about this?
This is the publication coming in with Bertillone and Hansen in Cura project book.
Okay, thank you.
Mm-hmm.
Actually, I have an interesting or a question about those Neolithic sites. It's quite interesting to me that Araujo seems to have quite a large number of ore fragments, azurite, it looks like, and that bead and maybe a couple of other pieces, and apparently now in crucible as well. And it's interesting to me that nearby, there are many Neolithic sites, in that kind of greater Marneuli area. Gadatri, Ligori, Miris, Shula, Eriskora, and to my knowledge, I haven't seen, mention of crucible bits or ore bits or something like that. Irina, do you think that is because nobody has kind of gone through the boxes and looked for them, or do you think that's just because Araujo is just that much closer to the Bolnisi, Saktrisi area, or is it just luck, or is there something else going on?
Also die Bolnisi und Saktrisi-Region ist die älteste, was in Georgien die erste Kupfer, also Goldberg, also Bergbau. Bis heute ist das das Bergbaugebiet. Das ist überall ist Bergbau, das ist jetzt Marneuli, das ist Saktrisi Bergbau, das ist die ganze Welt ist und dort ist und davon kommt die ganze erste Kupferobjekte und auch Eisen, auch Goldobjekte. Das ist also diese Anteile von Georgien. Also es muss man mehr forschen, weil diese Araujo, diese Crucibles, ja, das sind die ganz kleine Stücke. Also wir haben die alten Grabungen gar nicht durchgeschaut. Konnte das sein, irgendwo sind sowas, die haben das nicht geachtet. Und da haben sie keine so richtige Interpretation an der Keramik gegeben haben. Deswegen, also weil das ist die Chramistidikora und Aruklo, wo so viele Metall, kleine Stücke, Objekte sind.
So there's metal, small metal objects from
Yeah, the small metals objects from Chramistidikora and Aruklo. Yes, and this is the region with also is die Bergbau und mit dem ganze diese bis heute. Es sind sehr viele bergmännische, also Gruben, aber die Madneuli hat gesperrt dort die archäologische, nach dem Saktrisi-Geschichte haben die dort alles gesperrt für Archäologen. Das ist die Problem.
Yeah, because I understand that Aruklo was also excavated before the Kura project with Hansen and Mitskolava, but the new finds, the pictures you showed were from the later excavations.
Ja, in der Drebe, wir haben also sehr viele Fragmente von der Tigen. Sehr viel. Das sind jedes Jahr ist überall. Wir können in der Drebe keine Wohnhaus finden. Es gibt keine Wohnhäuser dort. Das ist ein Arbeitsplatz. Überall sind die Werkstätten. Und überall sind diese Bearbeitungsplätze mit der ganzen Menge Steingeräte. Und keine Wohnhaus. Also irgendwo haben sie anderes gewohnt. Und deswegen, wir wollen jetzt diese Wohnhaus irgendwo finden, weil das ist diese 260 Hektar völlig überall. Das können wir nicht so alles ausgraben. Ja? Deswegen machen wir so irgendwas, aber überall gibt es Gräber zusammen mit dem Werkstatt. Und was dem Gold jetzt betrifft, also was wir jetzt früher bekommen haben, die Gold, also kleine, also für die Bleisotopie, das ist die, also spätere so Bedenik, Trialetico, also Goldobjekte, aber die sind mehrfach geschmolzen. Deswegen, das kann man nicht finden.
Okay, thanks. My German is not so good. I got maybe.
Yeah, okay, but I'm sorry.
It's pretty bad, 30%, but I think I understood what you were saying. Magda, did you have something to add, or is that a
yeah,
legacy?
just like the small question, I was curious, like you mentioned, Irina, about the Chramistidikora, that we have some metallic like objects from the Neolithic time. And do we have some fragments of ceramic crucibles or other artifacts related to the metal production, or we have only artifacts of metal?
In Chramistidikora.
Yeah.
In Chramistidikora, in Chramistidikora is I don't know. We have I don't know. Die Chramistidikora, die Material ist nicht alles publiziert.
It's not published.
They're not also published, and also wir haben nur diese Metallobjekte und Abtröpfe. Also Abtropf ist Narwenti. Und Abtröpfe und das sind die metallurgische Produkte. Also metallurgisch, das ist nur nicht Rohmaterial bearbeitet. Das ist keine gediegene Kupfer.
Okay, just a drop of metal or the prills. Sorry, it's just prills, and there is no evidence of any ore deposits, like as I understood.
Is არის რა ნაჭედი არ არის და მეტალურგიული პროდუქტია.
Yeah, she said there is no evidence of the metal production in Georgian. Yeah. Thank you.
Thanks, yeah. Are there any final questions? I'm not seeing any other hands at the moment. In that case, I think our organizers, I think, will have a few kind of closing kind of remarks. Is that correct?
Yeah, like I just say, yeah, like I would say from the Caucasus Retirement Network Committee that like thank you for all the guests and our like wonderful speakers and moderator. It was great pleasure to see all these ongoing archaeometallurgy workshops, and we would be happy to hear more ongoing results. Likewise, if you are early career researchers and working in the Caucasus, and if you would like to present your research, please feel free and get in touch, and we would love to hear from your side. And have a lovely evening. Thank you to all. Bye.